Hello, how are you?
Pretty good. It says failure to access my camera, so I guess you won't be able to see me, but you can probably hear I'm on the treadmill.
Oh, okay. Yeah, that's good. Well, welcome.
Thank you. How are you?
Pretty good. Pretty good.
That's good. I like your little butterfly moth lamp in the back.
Oh, yeah. I use it as a night light when, the room is not very bright, like at night, so I wanted to be able to see to come in.
So lovely. It
Yeah.
also matches kind of what looks like snakeskin pattern on the right.
Oh, yeah, the curtains, yeah. Yeah. Well, hi, Jesse, how are you?
Good. I don't see anyone's camera, but I think it's part because of my. I'll change my device soon, and hopefully that'll help. But overall, I'm okay. It's been this is week 3 in Boston, and a lot of things are settling in their own time. The things are settling down, and it's nice to be here in this moment. It's a nice moment that I'm in overall. So I'm good. I think I'm still actually quite a bit recovering from the last several months of constant activity. So having a stable location is nice, and that it's in Boston is exciting, honestly. But yeah, that's
good. Good. Yeah, I'm glad you've settled in. You've seemed a little bit happier in the last couple weeks, like you've been able to settle in and start thinking about, it just seems like you've been rushing around all summer.
It's not really much of an exaggeration to say that it's just been 4 months of sort of like a vagabond, but a vagabond with very particular things to do.
Yeah.
And then it's like, oh, well, you finally hit the last port in your trip. So, yeah. But yeah, how are you? And I don't know. There's a slight chance that Anusa joins, and Avery may also join. I don't know if Aaron will join today.
Okay.
That's my sense of things.
Okay. Yeah, that's great. Yeah. Well, I hope some people show up and we can get an update. Otherwise, welcome to the meeting. So I guess the first thing we'll talk about is the Slack review, and then we'll go on to some other things. I don't know if anyone had any things you wanted to talk about later on, but we'll get to that as we go through the Slack review, and then we'll, of course, do papers at some point and go over like near-term deadlines and things like that. So I'm going to share my screen. Okay. You can see my screen here. All right. So the first thing, we'll go to the first channel I've noticed that we have content in. This was from, I don't know if we talked about this last week. I don't think this one. This was another post. I think I put that in from Johann John again. And he had a Twitter thread on category theory and non-mathematicians looking at category theory. And I know that Jesse's mentioned category theory a couple times, and I've been interested in it myself. And I actually attended during the height of the last height of the pandemic, I attended a lecture series. It was last year. It was put on by a group of people, John Carlos Baez, who's a mathematician, and some other people who organized the Zoom-based category theory meeting. And there's like a discussion group and everything. And so it's a very hard area to get into, like, casually. You really have to, spend some time like getting oriented to the language. So there's a lot of like jargon, so there's that barrier. But also just kind of conceptually it's different from like set theory. And it's based on set theory, but it's so, set theory is where you have different sets. You have, you organize things into discrete groups, and there are different variations on set theory. But category theory is quite a bit different. It has, functions between groups, and so you have categories, you have what they call functors or functions between those categories, and so it actually turns set theory into a dynamical system almost. And so, and you can also, use it in other ways, and I think we have a paper on it in the queue that we'll probably go over later. And so it's a really interesting area, and it has a lot of potential applications. I wrote a little bit about it in one of our papers for the DevaWorm group that we published recently as sort of a next step in developmental biology and understanding developmental biology. So, this is something that maybe if people are interested in, we can explore a little bit more. But it's interesting here. Johan talks about non-mathematicians looking at category theory. To get over the notion that set theory is the only way to view a formal symbolic system. Instead of isolated elements floating in a void, category theory invites us to foreground relationships, morphisms. So, the idea would be like you'd have this symbolic system. Actually, let me go over to my Jamboard. I'm going to draw this out a little bit. So, set theory is where you have these sets, and I'm just simplifying it, where you have these discrete categories. You might have like, like different letters, let's say, and they're just, different categories of letters. So say you have this set of symbols here, these are letters, they have some relationship between them, say, and we put them in these different categories, and the categories are distinct. So there's some properties of this category, properties of this category, properties of this one. They sit independently, so if you're going to learn, and we talked about Markov machines last week, so there are these connections between the categories, maybe state transitions that you can have, where, you can actually calculate the probability of moving between the states, but those are, they're almost independent of each other. If I move from this state to this state, or this state to this state, the identity is generally separate, and that's what makes them like coherent categories. In set theory, or in category theory, it's a little bit different. You have these categories like this. Let's say there's A and E, there's B and D, and then there's this thing called a functor, which is the thing that transforms this category into this category. So it's a little bit different in the sense that they're not independent. They're also not blind because there's probably some relationship between the two categories. And you have this functional sort of notation where you can actually show that there's a transformation between the two categories. So like in development, we're thinking about this category being some set of, maybe some set of products, maybe some set of cells that are undifferentiated, and then this category being some transformation of those, like the products acting on something or differentiated cells. Or, you could think of this as behavior. You have isolated symbols, and then here you might have like, things that are assembled into different permutations. So, you could have like different behavioral sequences here that are all, so the components are all kind of isolated, and then you would have like a system where you would put them together in this category, which would be much bigger, where you'd have all the possible configurations of it. And this functor would enable that. So that's the very basic level sort of application here. And so it'd be interesting to see, there's this idea of symbol grounding, and I think we've talked about this in certain papers where you have symbols that are grounded in a context or in something. So, you might have like a figure like this, This is supposed to be a vase. I hope it doesn't look too weird. But and then you have that, and that could be in isolation, so you could just see it. But if you put it in a background of this hatching here, then all of a sudden it has a little bit different identity. It's like you see the context or the background, and you can then you have to separate it out visually, or you could, I guess, touch it out with your hands with your haptic system. And so it's a different context if you have a background, and we do a lot of this background object separation. There's this idea of grounding symbols and a deeper meaning. So this actually would have like maybe a list of definitions for what it means. So this whole thing with the background and the foreground would have a different meaning than just the object itself. And so there would be another set of meanings here. And so this is what they mean by grounding, and it's kind of where you're embedding objects into a context. It could be an environment, it could be like into a set of predefined meanings, it could be in some generative meanings. But then there's this other system where you might have the components that kind of get assembled, and then you have this functor that allows you to build these sort of generative categories and have different categories at the other end. And then that would be, and so this is the way I'm kind of thinking about this. Category theory also enables things like anticipatory biology. So there's this book by Robert Rosen called Anticipatory Biology that people, I think, have followed up on since. It's not very mainstream, but it's the idea that your autonomic nervous system, which is your heart rate, or your some of your other systems like your interoceptive system, which is how you maintain your equilibrium and things like that, the internal sort of touch of your organs and things like that. All those things are sort of anticipatory. They don't really have like a cognition, but they have this ability to anticipate things and regulate themselves. So it's a nice step between cybernetics and cognition. So, and I don't know if we've talked about this in the Development group. Maybe we have, maybe we haven't. I know Angela has probably not heard of it. Jesse, I'm not sure if you've heard of it, but it's it's an interesting approach, because there is that space between sort of cognition and cybernetics that is left to explore. So the second tweet, though, is interesting. He says, some friends and I are struggling to learn category theory, but we realize we need to take a detour into topology. So why topology? Well, I guess there's ways that you can think about categories and their transformation that involve topology. So far, I think category theory might help with ontology. So these are like the sort of basis of categories. It might also suggest ways to model analogy, which is barely touched in cybernetics dynamical systems. So yeah, this sort of configuration is a dynamical system. If you have this transformation going on between categories, it's a dynamical system. This is a dynamical system too, this sort of Markov model, but this is where you really don't have very much sort of information driving it. In this case, you can specify some more of this information driving it. And so, this is an interesting way to think about it. Let's see. Okay. So, I mean, I don't know. Did Jesse or Angela have any thoughts on that? I just wanted to open that up before we move on.
No big thoughts, but definitely thoughts. So thank you for going over that. I'm considering topics that would be good to focus on in sort of a development of skill set for this upcoming fall semester, and I'm really considering those topics in particular, just because they come up. Category theory comes up quite a lot, and set theory and just even typology in general. Like they come up here, but yeah. Can you hear me? Okay.
Yeah, I can hear you.
Okay. So the broader thing would be what sort of a curriculum that we could think about topics in the fall, and maybe that'll be one of them. But yeah, thank you for the overview.
Yeah, I think that's and I'm going to get to it in a minute. I'm going to get to Zura's suggestion for that. So thank you for bringing up the thing about the topics. So Angela, do you have anything you want to say before we move on? Okay. No, okay, not really, other than thanks. So thank you. Let's move on to, let's see, the next channel here. And again, that was a very very basic introduction to that. I think it does deserve its own treatment. I don't think we have anything there. But yeah, I mean, in these topical reviews, I don't know how long they need to be, but we can talk about that more in detail. Looks like Erin made her own new avatar for her. She got a different email address, so let's see. Okay, probably in general. Let's check general. Okay, we'll talk about that. So that in general, there was this thing that came up this week. This is the Electric, which is the robot that Elon Musk is proposing that Tesla build, TeslaBot humanoid. So it'll be a humanoid robot. Will grab your groceries and perform other menial tasks. And so I didn't really catch the call for that. This is, I guess, the press release. So there's this humanoid robot for general purpose use, and Musk described Tesla as already being the biggest robotic company in the world, considering the capabilities of its vehicles to see and understand the world around them and act on that information. And so it makes sense for Tesla to use their significant advancements in computer vision, but instead of deploying a robot on four wheels, the company will do it for a humanoid robot. The Tesla bot will be geared towards doing repetitive and boring tasks. Here are the specs. So it's like a humanoid that is about 125 pounds, 5 mile an hour speed, 10-pound arm extend lift, that sort of thing. So, it's like they're instrumenting this humanoid model with all these different things like cameras, onboard processing, neural net planning, simulation and tools, dojo training, and that. So that's something, I guess the long-term vision is to replace most labor, and Musk reiterated his support for universal income, which would be required if the Tesla bot has the impact Musk is expecting. So this is interesting stuff. I don't know if Jesse, you wanted to talk more about that.
I haven't had a lot of time to go in depth about the video or like the reveal. It's interesting that he mentions the universal income there. Something to consider in sort of the ethics and society team setting is maybe about that topic in particular, because in so many words, I'm in favor of DBI, and I wonder what if I had another lifetime, I probably would be, like, my original path was for political science, and if I had another lifetime, I would be interested in trying to weave the political side of things together that would support that. But I don't have, it's something that I will follow up on, and I don't really know right now how much things are available from that to really investigate, but it's something to keep track of for sure. And I wonder what cognitive applications there will be for that that item. Similar, there's the. I think the next thing in the Slack is the conference, and I don't know if you give me, well, you can go through it yourself, but I can also go through it in a few minutes. I don't know what you want to do about that.
Well, I can just briefly mention it, and then we can go over it in more detail in a little bit.
Good.
All right. So let's see. I had a little bit of a problem with screen sharing here, but I think we're okay now. So yeah, this is the second part. Jesse's talking about the Coins Conference, IEEE Conference on Omnilayer Intelligent Systems. Cognitive Environment Track looks promising. So this is this coming week, I think. And this is the IEEE Coins. So we have topical area tracks, Internet of Things from device to edge and cloud, sensor and sensing systems, big data, data engineering, data analytics, artificial intelligence, machine learning, cognitive computing, intelligent robots and systems, distributed ledger technologies and blockchain, and circuits and systems for AI and Internet of Things. So it's very much in the hardware area, also robotics, and blockchain, which seems to be everywhere now. So, and then vertical tracks are smart city, industry 4.0, e-health and wearable IoT, agri-tech and smart energy. And then special tracks, critical system design, cognitive environment, which I think Jesse might talk about a little bit, machine learning, AI, clinical decision support systems for COVID-19. So this is all, I didn't put a link in here. We'll probably talk about this in a little bit. So we'll come back to that. Let's see. I'm looking for maybe what we have in the next one. I'm not really sure where things are in this.
Yeah, I tend to arrange that by last updated, and it helps a lot more than just
Okay.
Mostly there's some stuff on mission features, and I don't know if there's anything substantial in the open forum chat, but I mostly only updated mission features, maybe ethics tech, and open forum this week.
Okay. Well, yeah, let me go over open chat forum, and then I'll go back up to ethics and society and back down. This one is, I think this is all from this week, I believe. Yeah. So this is, this was posted on Sunday. Jesse, here's another Johann John tweet. This is the category theory tweet. So this was in a different channel, but we talked about that. So this paper here is a paper on what behavioral abilities emerged at key milestones in human brain evolution. 13 hypotheses on the 600 million year phylogenetic history of human intelligence. So number one is taxis navigation, and we've talked about that a lot in our Bradenburg vehicles work. So that's of course, so they're going from very early life. I mean, we're going from just prior to the Cambrian explosion, and we're kind of getting into multicellularity, and then we're getting into behaviors, simple behaviors like sensing light and moving towards light, or moving towards other environmental stimuli like we've talked about with taxis. And so I guess they do is they put this in a phylogenetic context. They look at if you take humans and some of our other sister species and you join them into a common ancestor, you you could model that whole thing as what they call a phylogeny, and then count some of the different behavioral adaptations on the branches of that tree. And so I don't know if they're going to show a phylogeny in here, but let's look at the paper. Oh, I guess this is because this link doesn't work right. What this link is. Okay, I can't get to the paper right now, but so this is an excerpt from the paper. There are two notable features of such taxus navigation in these model organisms for Bilateria, which are it's a common ancestor of all organisms that have sort of this bilateral symmetry. Cross-modal integration and valence. So cross-modal integration describes the ability to integrate competing input across modalities to decide whether to approach or avoid a cue. So this is actually, this is a little bit different than taxus. This is where you're taking in different types of inputs and you're making a decision based on those inputs. So you have taxus, or let's say, light taxus, phototaxis, and you're using that, so you have some sensor that senses light. So eyes are what the precursor to what we think of as eye. Well, what we have as eyes are very what they call derived, or they're very highly differentiated. But in a lot of organisms, especially going back 600 million years, you had these very simple sensory cells that were polarized by light. So you could have single cells that sort of would pick up light in the environment and polarize based on that. So there's some electrical activity in these type of cells that turns them on and off. And so we have similar cells in our own eyes, in the retina. And so that's a very simple sort of switch that it uses to detect the presence or absence of light above a threshold. So, you have those sorts of things. You also have touch. So even single cells have touch. They have this sort of haptic sense that they use, so they can sense pressure, they can sense being sitting on a surface, spreading out against a surface, and all these things. And so in these very simple early organisms, you had this integration of these two types of cues. You might have had they might have been able to sense light, or it might have been a small, multicellular organism, one set of cells that sensed light, one set of cells that sensed sort of its position or the surface that it was on, and then those would be integrated somehow, and then that's your cross-modal integration. And so they talk about C. elegans, which is a very, bilaterian with a small number of cells, but it has a pretty developed nervous system nonetheless. The decision by C. elegans to cross a copper barrier, which is a material that it can sense the chemical content of copper. It's aversive to copper, so if you put copper in a C. elegans culture, it will avoid the copper, and so if you put up a barrier, it can avoid that barrier, and you can sort of corral the C. elegans. If you put up a copper ring, you can corral them into a space. So if there's food on the other side of that, they will not be able to get to that food, but they can also sense the strength of the food smell relative to the concentration of copper. So if the copper sense the chemical concentration of copper is weak versus the food, so if they eat a lot of bacteria, so if you have this big glob of bacteria on the other side of the copper ring, they'll go over the copper ring and get to the food. So they can integrate those rival cues, but also they can also do the thing I described earlier, which is the having different senses in place. And C. elegans does a lot of that with chemical sensation and touch sensation. And there are different neurons and different circuits that drive those two things, but they can integrate those in their nervous system. And they have a nervous system of about 300 cells, so you don't need a lot of cells to do this. You usually have a small circuit to sense the one sensory modality, and then you have interneurons that integrate them. So this is the principle behind the developmental brain vehicles. our developmental Bradenberg vehicle is one of the things that differs from other Bradenberg vehicles is these interneurons that integrate things, and there's a reason for that. And so that's why that happens. Another example comes from flatworms. Flatworms will navigate towards a food cue even if there's aversive light at the same source. But if the aversive light is made bright enough, flatworms will no longer travel all the way to the food source. And the brighter the light, the further the food source they will end up, exploiting or not. This is what they call integrated decision making. So this is the other thing that they exhibit, which is the ability to integrate cues and make decisions based on that. So they're, I think, computational models of integrated cue or cue integration that exist in the literature that are sort of the basis of cross-modal perception. It's kind of an interesting area. They use a lot of Bayesian models for this. So, there's this idea that, you have one cue given another cue, and you kind of append, you have this prior distribution of the cue, and if it's getting stronger or weaker relative to the other cue, then you know when to exploit this resource. So there's a lot of stuff you can do with building models like that. This type of integrated decision making was also shown across numerous modalities such as mechanosensation and thermal sensation. And this is in the flatworm, which is another organism with not very many cells, and so they can do this sort of behavior. There's also valence. So valence refers to the ability to change decisions based on internal states, hence representing an ability to make decisions depending on what an organism needs. The concept of valence modulated by internal states is a foundational component of motivation and learning theories and behavior. So, for example, in C. elegans again, food smells that trigger an approach when hungry, or trigger approach when hungry, often have no effect when well fed. So, in other words, if the organism already has eaten recently, it can have a very strong smell of food around it, and it won't feed. There's no signal for it to feed. But if they haven't eaten in a while, then that they're using chemosensation to pick up the smell of food, they will go for the food. So this is something that is sort of the strength of the behavior, the strength of the motivational behavior. And so this is something that is the other feature of herb bilateria. So this is actually quite widely present in a lot of bilateral organisms. Some cues like carbon dioxide, which can signal both food as well as predators, shift from attractive when hungry to aversive when well fed. So this again is something that where you get other cues that maybe aren't necessarily directly related to food. This might relate to food quality, because remember they eat a lot of bacteria. This can signal both food and predators, and so you can, there's shifts in behavior depending on, whether they're well fed or not. And these things, of course, maybe integrate. So you have information that's being integrated across different senses and affecting valence in that way. So those are the features that they're talking about in this paper. And again, I can't get to the paper right now. This link doesn't work, but Adam Filipowicz says, responding to Johan, says, I don't know if this is in the review, but C. elegans are also initially attracted to certain pathogenic bacteria, but then switch to avoiding them after infection. They can also discriminate between bacteria of different food quality. So this is what, we're talking about with valence. So, there's this a bit able to sense food quality and pick it out. So this has a lot of good implications, I think, for some of the Bradenberg vehicle stuff too, because, we've been working on this idea of developing circuits that, are sort of, kind of developed, they kind of grow from maybe nothing, or, an initial sort of blueprint to this adaptive system. And so these are the kinds of things that, Brainberg vehicle can produce these types of behaviors. And so they're very simple bilaterine behaviors. And so, this is kind of useful for looking at a very broad definition of intelligence. So in C. elegans, you can see these things. And these things, carry on to humans, although the circuit in humans is much, much more complex in terms of the control system. But, you still have these basic behaviors. You could observe them. It's not like it doesn't change that much over evolution as things evolve. You still have that basic function, although it's augmented with other things as well. And other, like invertebrates, you have more elaborate systems for this, regulatory systems, and as well as connecting to other behaviors. But I think this is an interesting paper because it kind of gets down to some of the things that. If we want to think about like a very broad definition of intelligence, I think this paper would be useful for this. And I don't know if they did this in the paper where they displayed like a phylogeny of these different things, but I think, this is probably useful as well. So yeah, we'll revisit this paper maybe next week too. We'll want to follow up on it. I would definitely recommend that. So this is the thing that Jesse was talking about with respect to the list of topics. So did anyone want to say anything about that last paper that we talked about? The phylogenetics of behavior, simple behaviors. We're going to be turning our attention back to some of the Brainberg vehicle stuff maybe in a bit, in the next couple weeks. Go ahead, Jesse. Oh, he had to disconnect and come back on. Yeah, let's wait for him. How are you doing, Angela?
Pretty good. Sorry, I have myself on mute because I'm disturbing you guys with the sandwich treadmill.
Oh, okay.
It looks like you can hear me.
Yeah, I can hear you now.
Okay. I was just saying, basically something to be followed up on, and I think, I don't know if this would fall more under cognition futures itself, or developmental AI, or both, or whatever. Doesn't matter. But I think between this and sort of like the Paul Kysek talk that we mentioned a while ago, and a lot of the work on what we did at the Cognitive Science Society wasn't of the same. That was a talk about the field of study of cognitive science and psychology themselves and development in it. But I think I think these are things. I think this kind of I think these are forming kind of a curriculum of developmental stuff, and I envision building that out a little bit in the future, because I'm very particularly interested in papers like this one where they go through at different stages, of macroevolutionary context, and also micro or individual as well, but particularly the bigger pictures. I think that's something that I'm interested in, and I think having a little bit of a curriculum development, or just this kind of fits in the category of, this is a nice area of understanding to develop, and it may not be directly attached to some. It's not a direct it's kind of a historical thing almost, but I think it's quite useful, or at least interesting, if not indirectly useful. So yeah, there's a the short version of what I'm saying is this would be an interesting part of a curriculum that's developed up to a developmental curriculum, and whether we want to, I don't know how we want to frame that in the lab, but there's stuff that can be done there. Yeah.
Yeah, and again, we'll be revisiting this, maybe even in this Metabrain models paper. I'll talk about that in a bit, but there is this issue of I've been working on it, and it kind of comes up that we talk about development and evolution in it, because these are kind of linked to the. I wanted to put some content in, but I also wanted to bring kind of together a lot of the work with not so much explicitly developmental Bradenburg vehicles, but some of the same issues, and bring them forward with Metabrain models. And so,
yeah, it was really interesting. I don't know if the paper. I imagine they do. I imagine they have to. I would be surprised, and I'll try to find the actual link to the paper, but I wonder how much they draw directly from Bradenburg, because that's one of taxis and cross-modal or bilateral differentiation, integration and stuff. That's classical. That's very core to.
Great.
The concept of vehicles themselves, and also just even when it'll be really cool. Maybe I'll try to dig around and try to find the Paul Kaisik talk on Johann's stuff and try to compare. It'll be a really fun exercise to go through that paper that we just went through and Kaisik's talk and do compare and contrast and see where they line up or not. For those who don't know, the Paul Kaisik talk is kind of this tiered evolutionary tree or set of divergences, and he kind of went to the different foundation points, when did the spinal cord evolve, when did the sensory organs kind of separate from your eyes and your nose, and integrating those things, and obviously becoming different variations of vertebrates and invertebrates, the whole scope of how each of those sort of hardware or physical changes, embodiment affected cognitive capacity, basically.
Yeah.
And that's been a long-standing theme of the lab, and not just in the lab, is how our cognitive capacities affected in development. So yeah, I'll leave it at that.
All right. Yeah, it's pretty good. Okay, so actually, I wanted to mention, I don't know how long Angela has before she has to leave, but I did want to bring this up before I go to the next thing. So I mentioned to Angela, I think in a Slack chat or message, that I was planning on doing a talk series. And this is sort of in lieu of the special session that we had. I think I'm going to roll this into a talk series that we'll be hosting. And it's going to be on a number of different topics in tech. And so I know that I asked her if she wanted to present during this talk session. So this is a 30 to 40 minute session. It would be hosted at a university, in a university setting. It'd be a hybrid talk. And she said, yes, I'd be interested. So this is for the data trust stuff. And so, Angela, I just wanted to confirm that you wanted to do this, that if you had any questions about it, I can answer them now. Okay. Yeah, she has no questions, but she'll do it. Yeah, that's good. Okay, yeah, I'll work on it and message you along the way. So this would be sometime in late October, November, so it's a ways off yet. I have to reserve space and reserve times and everything. I have other people I'm scheduling in, so I'll let you know when I have a date. And then I don't, because you're in Germany, I wanted to make sure that the time would work. So it would be like either, in where we are, it would be like morning up till about noon. But I don't know if you have scheduling conflicts with doing things like in the evening or in the late afternoon. Is that something that you can do, or? Okay. Yeah, I'll give you a target time, and if that doesn't work, we can reschedule it, or I can give you 2 potential times, and we can decide. Because I wanted to make sure that it's the scheduling is always an issue, and because we have to get a room for that on my end, and I have to do that scheduling part. So, I look forward to that. That's going to be exciting. And then this talk series, and I'll talk about it more. Yeah, good. Thanks. I'll talk about it more when it comes together more, but basically it's a series that is it's hosted by the Rockwire Initiative, the Rockwire community, and I'm bringing people from different parts of the University of Illinois campus together. They're going to give some talks on different topics. I might get some outside people from one person, maybe from Verizon, is going to talk about mobile technology, and then Angela. So it's going to be a very eclectic series, but it's going to be, I want to give people exposure to sort of, some topics in tech, also some things that tie into what I'm doing in the community there. So it'll be an interesting session, and they should all be recorded. So this will be like in October, November. So this is a ways off yet, but we'll have more. I guess I'll talk about it more when we get there. So that's good. Let me go back and share my screen again. I wanted to go back to this issue about the different like topical tutorials. So Jesse says, I'm putting together a list of topics that might be good to review in a regular segment for our meetings this fall. And I'm quite curious what other people would like to focus on. Specifically, these will be technical topics as opposed to concepts. We will certainly have a place for conceptual, non-technical talk, but one thing Bradly and I talked about is having a renewed focus on some of these tools. So these are, Jesse planned to do some things on deep learning, data and stats, but we want to cover a lot of topics like reinforcement learning, category theory, topology, data science very broadly, and then things like Python, R, PyTorch, TensorFlow. And so this is something he's been soliciting people in the lab for. We have, if you're interested, DM myself or Jesse on this, or you can leave a comment in the open chat forum channel. That's where we're having this conversation. It's actually branching off of this message. And so it'd be like a 5 to 10 minute presentation. I think that's pretty good. It's just like in 5 to 10 minutes, you can't do very much, but you can give like the basic sort of essential nuggets of information. So this would be an exercise not only in like presenting a method that you know somewhat well or are familiar with, but it would give you this sort of discipline to sort of find the essential pieces of the puzzle. So, what are the like top 3 things we need to know about reinforcement learning? What is it? Like, what are the top 3? There's a lot of reinforcement learning out there. There are different variations of it. And, you could talk about it for hours. But what are the top 3 things that we need to know about reinforcement learning? So that's the kind of thing we would want to do. And it would be like, there are a lot of tutorials out there. This is a thing that, I guess, the comment I had about this and thinking about it is there are a lot of tutorials out there, a lot of ways you can learn this stuff. Like I could send you to a reinforcement learning course, and you could learn a lot. But I think this is valuable in the sense that it's a very short primer. Maybe it gets you to a place where you can understand sort of the very broad nature of reinforcement learning. I think we've talked about before about how it has roots in behavioral psychology. So that's something that is not stressed probably nearly enough in the literature. People might mention in passing, but there are a lot of consequences to that. there are a lot of parallels between like animal behavior and reinforcement learning algorithms. But to really boil that down to like a couple of points, what do we want to know about it? How do we want to think about it? And so this is the thing where we have this resource as a lab. There are other groups doing a lot of other things on reinforcement learning. There are courses you can take, but we want to create something that's sort of our own signature thing here. And I know that's a lot to ask, but I think it's something that. So here, Zura actually proposed something. So he is planning to go through some papers that explore the connection between reinforcement learning algorithms and dopamine-based learning in the brain. And so this is the DeepMind article he's referring to on this. This is just one example. This is the relationship between neuroscience and AI, and like I just mentioned, that's a very rich area. And this is where they talk about this dopamine signal. So the dopamine signal is a thing in the brain that drives reward. If you eat something that is tasty, there's this reward for eating it. It might be like cherry pie or something, and you eat more of it, and you learn to like it. And so every time you see cherry pie, you get excited or something, and it's rewarding to have it. And so there are a lot of different things that you can learn, because it's not just a simple positive feedback. As it turns out, the dopaminergic circuit, and people have modeled this using sort of a cybernetic sort of language. There's a lot of complexity to this, especially in human brains, where we have people who are treating addiction are often very interested in this area of this dopaminergic signaling pathway. And so it's interesting to see what's going on there and then transport that into the world of algorithms. So there are a lot of examples of work that's been done, and people are even, like I said, in like addiction research, people are doing a lot with modeling this pathway. But in the computational world, people are looking at things like temporal difference learning. So this is a way to kind of model that reward structure. There are also links, maybe even with game theory and modeling, different payoffs for things. So there are all sorts of ways you can explore reinforcement learning. There's this link between behavior and algorithms, and there are aspects of reward that are not covered fully in an algorithmic approach that are essential to the biological approach. And so this is the kind of thing maybe we want to explore. And I don't know how this will turn out, but I think this kind of approach that Zura is proposing, and I've done this before, Jesse's done this before, where you just take a couple of papers, and Anusha has done this, where you just take a couple of papers and you kind of build something around that. So you just take, you take a sampling of papers and you find how to pull those together and talk about some really obscure topic like, dopaminergic signaling. Like if I had a dopaminergic signaling of algorithm where was maybe like a cybernetic type regulation where, I have positive feedback, I have a feed forward signal, I have negative feedback, I have, other components to it. And that's what that's the kind of thing I want to talk about. I want to bring some papers to bear. I also want to talk about some specific methods because, we've been talking, and this is where it kind of gets slippery. I'm kind of moving off into the conceptual lane here, but I think like the key here is to know maybe something about like temporal difference learning. All right, so you want to like cover this topic, but you also like this algorithm, maybe lay it out a little bit. If there's some equations, lay the equations out, sort of, so let me see if I can do this on my board again. This will be a little bit easier if I visualize it. So like say for example, you have an equation and you have, and this is a good way to present equations. It's a very long equation with a lot of terms. But one thing you want to do in a presentation is to take that equation and break it up into parts and then describe the parts. So like if I have an equation like for temporal difference learning, this might be the function here, and then this describes the parts of the function. These could be additive, these could be subtractive, they could be, whatever. The operators are in between, but you want to describe each part. So this is like part A, this is part B, this is part C, right? And so you have this way of describing this long equation that isn't like, where I have to stare at it and figure out what's going on and not understand it. I want to be able to take each part and analyze it. This part of the equation might relate to dopaminergic signaling. So we'd have like part of the equation A. Don't worry about what the term is, just worry about what this is, and then maybe how it's modeled biologically. And then just repeat this across, and then we have maybe a more intuitive understanding of this function, but we also get the technical treatment because you've listed the equation here. And so people have worked hard to kind of boil this down to a mathematical representation, right? I mean, they're basically taking some natural process and they're boiling it down to this equation, right? It's not perfect, but it describes the regularities in it. But in this case, you're going backwards and you're reverse engineering it. You're saying this part of the equation means this. This is how it works in nature. And of course, it's incomplete, but this is what it's supposed to mean. And then we could, we have an understanding of that intuitively, and we can get a better handle on it. Or, you might have a network, like a connectionist network, where you have, maybe inputs like this. We want to understand the weights. If you, draw things out visually like this, you can see that there are weights here, that they're nodes, and that they're coming together in a common place. And then we can you can cross them out or give context to some of these nodes. Like this is a neuron, this is actually a motor neuron, because you wouldn't know that from just this little node. So, spell things out like that. Draw the connections between, say, like the biology or the psychology and the model. And then describe the technical aspect of the model where you have the technical detail of it. So we know kind of how it works, but we also know how it ties back to the system. I think that's a good approach, but it's hard to do. So this is something, I don't want to make this too onerous for people to participate, but I also want people to sort of, do this in a way that's very unique to the lab and very unique that helps people understand things. So Zura wants to do this presentation. I would recommend it. Definitely, Zura, if you want to do this, it's a great first example of this. I might try to do some. We have some topics here. These are not exhaustive. Reinforcement learning category theory. I might do something on network science, but we'll see. I've been wanting to do this all summer, and I'm like Jesse. I've had so many things go on that I haven't had time to do it. But this is something that we can do. I think it's a good little chunks of knowledge that we can advance. So we can have a collection of these at the end, and we can sort of show new students and say, this is what we want to do in the lab. This is how we're doing it. So Jesse, any thoughts on that?
I think that's good. I think I think there are different. I like how you mentioned it being ways to make it specific to the lab, and to situate it a bit more, there's one of the things that I'm playing around with is how much could and or should we part of our lab is sort of education and outreach and creating. There's a developmental development in a different sense than what I said last time, but a developmental sense of stuff that affects what we're doing, and it's sort of how do we want to best contribute to that? Because we could be very formalized and structured and creating. Here's a curriculum on for the different projects that we have. We could do like a Cognition Futures curriculum or a Developmental AI or Metabrains curriculum. Or, and then they could be really planned out and informal and whatever, or more so just like, we have a set of topics that we come up with that we want to do, what people say they want to do, that fit generally with, that fit with a lab, and then we potentially curate or organize them in different ways of like, hey, you may want to check out these things that we talked about that fit with this general area, just to give you a sense of background of what we're trying to do and working on. And I haven't yet decided how to best approach that in specific. One thing that I wanted to do this week but didn't have time to fully put together in a way that I can show people yet is kind of explaining the different, like for someone who comes to the lab, they probably have no context what. Now, like you can play around on our website, but I kind of want to create like a sitemap of, Cognition Futures, Metabrain models, Developmental AI, Ethics Society team, and like how our major projects are situated, and not to differentiate them so much, but more just explain where we are. And there's the research that we're doing, and there's also sort of like the side component of basically this stuff, which is we have quite a bit of educational material spread throughout what we've done through, the various things we put on GitHub, and it kind of comes back logistically to that question also in an administrative sense: is do we want things to continue to be on GitHub? Do you want them to be in Notion or in some other place? And I'm not sure yet about that. I had a conversation with Bradley about that last week or so. Like administratively, do we want this to be? There's a lot of different ways you can do it, like in a standard GitHub repo. You can do create a GitHub web page or a GitHub account that shows that kind of displays like a more interactive web page rather than just the GitHub.io actual address. There's a lot of questions about that, and on the administrative organization or back-end sense, I'm hoping to come to those conclusions in the next week or so. But outside of that, I think going back to the, okay, here's a structural lab, here are some topics, here's some like project in the lab, here's the research we're doing, and then here's sort of the curriculum and education component. I think that would help, and also and make some clarity for, because people come to the lab for a lot of different reasons, and as we say often, but not everybody comes to these meetings here and does things in these meetings what they're doing. But like Krishna has created a lot of materials and education and presentations about stuff. Rashad has as well, but they haven't actively been putting them in the meetings. In like they're not here presenting what they Bradley did today, but it's not that there's not activity going on here. So I think one of the, in a lab manager sense, and administrative challenges, how do we actually put that in accessible ways, but also saying yes, it's not just sort of an empty directive like, hey, let's learn some stuff this fall, but there's sort of a the educational component, and contributing to it is I'm kind of giving a higher level how does this integrate thing, and that's great, but also like that if you just want to talk about reinforcement learning, you can. If you want to go deep dive into category theory, or like Anusha's been interested in a lot of aspects of developmental psychology, and like if you want to just have a place to do that, that's great. That's available. You can just literally do that, and then especially if finding ways to tie it into other projects are ideal and will be done. Those ties will be made one way or the other, but just like it's sort of in one sense it's simple as plug and play. Like if you want to talk about a topic, go and do it. But in another sense, in a constructive sense, for like an educational sense in the lab, I'll have some tie-in, and I'm trying to create a structure where it's easy to sort of have like if someone just wants to come and do it, they can just do it, and then I'm going to try to work on making it more, weave it into the tapestry of our lab and our educational stuff that we're doing. So that's my pitch about that.
Yeah, I'm just writing down some notes. Yeah, I think I like this idea about weaving it into a curriculum, because we don't want to there's you could plan it sort of top down, where you have I'm going to create this curriculum on X, and then you tell people you have to contribute to this area, but not ever. We're pretty diverse in terms of what people want to do or what people are doing, and so I want to give people the ability to sort of explore niche topics, and then we can kind of bring them together in a curriculum. Another thing, of course, is to do based on the project. So that's a good way to solicit people's involvement in projects, is to have educational resources, and then those educational resources would build interest in doing other things like papers and other things where you have this active involvement in the topic. So people are learning, people are producing scholarship, and it's sort of self-sustaining in that way.
Yeah, and I can envision a few different ways of I can envision some very clear even a simple Notion page where you kind of have a project description, a relevant image. Here's some work we've done in the past couple of years about this in the lab, and then research outputs or whatever. Here's some topical, educational components we've had, or links to our repos and things like that. And also, a curation of a lot of external resources that we've had, that page, the Metabrains page, that's the list of resources. I don't have that up right now, but just that's a nice resource. Than just having I think we can have a lot of those things for the different components that we have. There. And this is sort of an this came together quite naturally. I don't think it's very publicized. I'm sure very few people have actually seen this page, but this came together over a lot of different things from Neuromatch and associated things in A-Life, plastic theory, and everything else. And if you scroll down, you can see there's a set of resources that have been there, and some of it's stuff that we've done, and some of it's stuff that created outside resources that are quite relevant to people wanting to do it, And I think that's I think, and this isn't something that I think. This is kind of a lab administrative thing, but I think having some nice visualizations of, and by visualization I mean basically a website is what I mean. I don't mean an actual visualization, although that would be cool. But having a way to easily see what's going on in these different areas, because I feel like there's a bit biased, because if you've been in the lab, and this is true everywhere, but I still think there are ways to do it better. I've been in the lab for a long time,
and I know the lay of the land and the trajectory of how that evolved. But for people who, like, I'm thinking a lot about the upcoming fall semester, obviously, and it's almost here. It's the 21st, for the 21st. So, I think having ways to just for people to see what's going on, what to do, what they can do in an easy way, and seeing it's tough because since we've covered so many different things that I think some structure might help convey that. So, yeah.
Yeah, it's also sort of this institutional memory that we want to convey. Like, there's things we talk about on Slack and things we kind of do and forget about. And then, we want to bring that out so that it doesn't get lost. We can build on it.
I have a question for you, Bradley. When we use the shared Notion stuff, were you able to edit that page yourself when you got the access as a guest, or we could only view it?
I can't remember right now.
It's been like over a year ago.
I may have been able to edit it. I think I think the permissions might be a little odd, but
because like the thing is, anybody here who has an EDU email can get a free upgrade to Notion, but I forget how much collaboratively it has, and because like part of me, Notion's awesome tool, but it can be a little bit isolated, I guess. It can be almost too discrete from a lot of the rest of. It's not as accessible, like, whereas GitHub is like complete accessibility.
right.
Like, you can just go there and anybody you can go to any public repo and make a comment or a change. So that's weighing on me quite a bit, and I feel like I just have to make a choice about do I want to try to do with Notion or not, which is a lot easier and probably a lot less intimidating for people who don't want to deal with GitHub and don't want to deal with Markdown or don't want to deal with the libraries. But yeah, so
yeah, I think a good way to do that though is to have like multiple modes of interaction. So making GitHub one option and Notion another option if you don't want to use GitHub or don't want to learn. I don't know, but having those different paths. It's good for accessibility, so people can do. And the downside, of course, is that things are splintered into different places, but that's okay. I mean, if it's only 2 or 3 places, those can be synchronized. But also to just make sure people know what to expect. Like, what can I do with Notion? If I can't edit in the same way, how do I submit something? And just give them those rules up front, and then that would be.
And I think I think it's a good point. And I've had interest in my assistant lab manager, like, teaser preview when I talked about that. I've had people reach out to me saying, "Hey, I would like to do this." So I think it's also something that could be, a little bit of administrative help, or just me doing it more. Like, there's ways to aggregate them, and I think. I'm kind of leaning towards using Notion to aggregate them at this time, but we can talk about that. We can move on from that for the meeting, but if you're still open to Notion, I might try to use Notion more for this. So.
Yeah, I'm definitely open to Notion, and I like it. I mean, it's not perfectly functional, but nothing really is. I mean, depending on the way you look at it, like GitHub isn't perfectly functional in a lot of ways, and you can't. You have to create a table. It's kind of a pain to do that with Markdown, but it's hard to edit. Whereas in Notion, it's a little bit easier to edit. But I mean, there are all these pros and cons, and I would just give people the option to do 2 or 3 ways of interacting, and just let them know kind of how you expect them to do things. You could have like a set of guidelines, and then we can just integrate across the different platforms to get what we ensure that people can contribute and get their work into the system, and then we can work from there. And I think that would work out. And as for in terms of management, if Notion is the best tool, I think it's a pretty good tool. We could use that. I don't know how much editing we need to do, because the management, the admin stuff is a lot more closed as a system. We have like 2 or 3 people interacting with it. It's not like we have like 10. I mean, we don't really have 10 people interacting in any one project right now, but you get my point. It's a smaller group, so it needs less permissions structure. I think that, we should definitely, I would just do that, go down that path, and if you have questions, raise them in Slack, and I think we should work towards like some sort of test of it too, just to see how it works. We can test it with a couple people and see if it, how the permissions work and everything, the practicality of it.
Like one easy thing that I can do with this now and have that experience is like just kind of updating condition futures page, and also potentially making a something for the ethics team as well. Like those can be kind of guinea pigs because they're happening anyway, and they're kind of one's in Notion already, and one is almost there fully, and I'm updating my own website, which is kind of GitHub based right now anyway. So it's something to settle down and move on to other things now.
Okay. Well, it's good. Let's keep up that conversation. It's a good thing to keep on top of, and we'll try to do some more recruiting for fall and try to figure out where we, keep working on our plans. I did want to go to Ethics, Tech, and Society. I think Jesse said he had added stuff there. We had, that was the maturity model thing. This is the thing, I think, from this week. Maybe we didn't go over it before. Oh, we did go over this, the moral consideration of artificial entities. So I don't think there's anything to review in this channel, but virtual reality, that's okay, nothing new there. And then research questions, nothing new. So I think we're all caught up on the Slack. So that's good. So that's our Slack review. I wanted to kind of quickly go over the submissions page, just to keep us on top of this. We have 2 things that are really kind of with deadlines. I'm going to put them in the red zone because I think we're probably at this point now with this paper here, or this pragmatic CGS, which we haven't really started yet, but this is due in early September. And then there's this thing, Metabrain models paper here, which is this thing that's due at the end of the month for the Embodied Intelligence ebook. So, and then this, I haven't heard back about this submission to the International Society for the Study of Information. I don't know what happened there, but, we might hear back from it. There's also this continual embodied learning paper, which is already kind of there, but we need to make it better. We need to revise it, change some of the issues with the figures, and add more details. So that's due kind of at the end of next month, or September 18th. I think they might extend it. But this embodied intelligence ebook chapter, that's something that I've been working on, and I think I made it public this week. I sent it to, I think it's in the Metabrain Models channel here. So if we go to the Metabrain Models channel, It was posted here. This is just kind of an update on, this is just showing the document. But this is the latest version here. I have the abstract, which has been trimmed up a bit, shaped up, and working on the introduction, justification of work and prior approaches, basic architectures, level of representation, and then some issues surrounding that. So there are a lot of topics are kind of putting together in here. Cybernetic regulation, which is a topic that we could spend like 20 pages on, but we just need like a short thing on it. Innateness, again, this is something that is like this lower level sort of model of sort of if you want to have a basic model of what the phenotype should look like, you have this innate component, but you also have this generative component that is realized through development, and then there's this evolutionary part that's more kind of the consequences, and then this application of Metabrains to specific systems. This is an area that I'm not really sure what we should mention here. This is like, applying these things to specific systems. So we've talked about different technologies. We've talked about, virtual reality. We've talked about AI. Robotics and things like that. Some of the topics in applied AI. But there are also things like, navigation systems. And I think in this section, the application would be to specific domains where there are, like certain problems that the model is solving. So like, let's take navigation, for example. Navigation would be like, you'd use a Metabrain to allow you to navigate better. Why? Because those different layers are interacting. They're giving different types of information. You can get you can do say, machine or computer vision, and you can analyze a scene or a set of scenes with the lower layer, and then the upper layers maybe provide some sort of semantic content or context to the images. So you have this semantic layer, you have this basic layer that allows you to do a lot of segmentation and image processing, and then that's all sort of makes navigation better. We haven't tested it on that domain, but it's just a suggestion for future work. And then finally, moving this towards sort of looking at the developmental AI paradigm. You were going to say something, Jesse?
Oh, sorry. I think I wasn't at my computers.
Okay, yeah. So Angela had to leave. Thanks, Angela, for attending. But so this is the developmental AI. So this is what we were sort of the thing that I presented on in the meeting itself, and then I don't know if Jesse, you want to add any. I don't know if we need to add anything on like cognition futures, if that's something we want to, if that's something that's relevant or where it's relevant in here.
Yeah, I think this is going to be. I thank you for doing this so much so far, and this is something I'm going to be going over again and actually fleshing out a bit more. Is this has like kind of a loose word limit to it, or?
In the email they sent, it was like, I think the limit was like, they said it was a short paper or it could be a long paper. The short paper is like 3 to 6 pages. The long paper is 7 to 20 pages. So I guess if it's 6.5 pages, that's no good. But like 7 to 20 would be okay. I don't. Yeah, I think we're beyond that. I think we're in the big paper category, but I think up to 20 is the word limit. And we have a lot of room. Yeah, it's like we're at 10 now. So.
Okay. That's kind of what I thought. No, I have not really added anything to it so far, and I will do that today. And it's very good to have this so far.
Okay. Yeah, this is just synthesizing a lot of stuff we've talked about in the meetings, but we've also done. And there's I think a lot of citation left to do. We have to get like, if you see something in here that you think there's a good citation for, please put it in, or at least put a note like that, because I mean, like some of this stuff, like cognitive offloading, I put something in on that, muscle synergies. Just is I've just been putting them in as I thought of it. Subsumption architectures. Yeah, these are things that kind of thought about and then put the reference in. Actually, this needs the reference here just to put it in the right place. And so I don't think you can ever have enough references, especially when we're doing something like this, which is kind of a tour de force. And I think embodiment is particularly, we need more references on embodiment and maybe more detail on something about embodiment. Like, what is it? I think we've been talking about the power of embodiment, or why is it critical to intelligence. And yeah, we do have to add in those, let me see, I think we do have to add in those references that we talked about today. Let me make a note here on the Cysic and other reference. I think I'll know what this is. You'll find that, like, sometimes when people write, you're writing and you get to a point where, you want to, like, put the references, but you don't want to stop writing to put them in. So you just kind of put a note in for future reference. And you're thinking of a reference and you can't really get your head around what it is, but, like, that, like, kind of what it is if you, like, give a sort of a weird name to it. That's what this is. Hopefully we get it. The problem is if you do this too much, sometimes you forget what the reference is. So, it's just management decisions, But I think that's great. Please go over this and we'll, add what you want. And, especially if you have references. I know you have a lot of references on embodiment. And if you can't figure out where to put it, leave it as like a big commenter at the end where you can put in like, this is what I want to say about this. This is the reference, and then I can fit it in somewhere. We'll have to think, because we'll probably have to do some reorganization even still. I've tried reorganizing it a couple times, and it just makes sure that it flows well. I think that's critical. But I think it's coming along. I think I don't know if we need any figures. We may need figures, but that's another thing we might do, like some diagrams of some type where we can diagram out some of this stuff. It makes it a little bit easier to swallow. I need to add one on so we have those figures from the talk on Metabrains. I know I have this. Oh, I need to add in this figure on like a basic Metabrain diagram. And then that's like one of the figures. And then maybe some other figures. But, just so people, it makes it easier to go down if you have figures. Because you're reading through this and it's just like you're going all over the place. You're ping-ponging back and forth between all these things. And it's like integrating it is tough sometimes if you don't have a good figure. So...
Yeah, that's good. And I'll come through we have a bunch of references in Zotero that probably will work out for this, and we're making it just a set of them there, like a little folder for all of our references here will be good.
Yeah.
Okay, and I think honestly after the meeting too, I'm going to go over the submissions document again with you, and I think I'm kind of like getting back up to speed after the summer away. So I think I've been a little bit. There's some stuff that feels a bit rusty for like lab management stuff, and I have to yeah, I want to get the rust off.
Yeah, yeah. Review.
Yeah, I don't know what else you wanted to talk about today in the meeting.
Well, I'm going to go over the papers, but I didn't know if there was any.
Over the conference.
Oh, yeah. Let's go over that too.
And just in part because, not that a whole lot. I might share my screen.
Okay. Yeah, you can do that.
Here we go. Yes. Oh, it just decided, like, there's no option here. It just, yep. Okay.
There we go.
I guess can you see my whole?
Yeah, you just have to go to your tab. All right, there we go.
Does it? You can still look at it.
Yeah, it's fine. Yeah.
So, I think they just updated their website. So I'm a bit confused now as to where things are in it, but here it is. Conference on Omni-Layer Intelligent Systems. Adding new dimensions in the future of IoT and AI ecosystems. New technologies. I don't think there was another. Like, this is actually the main the registration page that I've seen. But you know, standard conference stuff. Here's the call for papers and stuff like that. It's in Spain. I wish I could go to Spain, honestly, but I won't be doing that for a variety of reasons. Here are the different tracks. Now, we did go over these before, but I don't know what these special tracks mean. I've been trying to figure out what they actually mean. But just to give you an overview of the schedule, it's this upcoming week. It starts Monday. These are CET time, so it's kind of afternoon in Europe, and it starts in the morning in the eastern coast of the United States. The green rooms are sort of their major speakers, and then in the middle of the day they have these sessions. IoT, sensor systems, e-health, and so on. And then a lot of stuff on blockchain. In theory, I really want to check out it is kind of hardware based, you know, but there's some specific things I really want to look at. Intelligent robots and systems, yes. And then obviously cognitive environment track, but I don't know what that really is. I'm a bit stumped as to what that is. Okay, this is again on their main page, thiscoinsconf.com. But when I go here, I think the lowest. Apparently it's already here. So I tried it, so congratulations. And the keynote speakers. And I guess it's just this, but when I click on this, I don't really know what this is. I don't. I'm hoping that somebody sees something and let me know about it. But I have no, like, there's not really, like, I see topics. I see members, but I don't see like date or time.
Oh yeah.
And you know, this is the call for papers, but going back to the schedule,
it's not on there.
Search for cognitive. No. There's the cognition. Let's zoom out a little bit. How do I, hold on here. There we go. Recognition.
Yeah.
Well, cool. But like, I don't see what is this? What is this called? Cognitive environment track. Yeah, there's no cognitive. So I will be reaching out to them to see what. Maybe I can look for track chairs. Lorcio. Maybe I'll search for this name. This isn't really the most articulate way to do this, but we are. Yeah, I don't see anybody with this stuff, but
So what is it about? Like, let's go over that.
the conference itself.
No, just the session that the cognitive environment. Like,
Well,
what is
in theory, it's concept of IoT solutions by applying smarter cognitive environments, by leveraging global connections of billions of tiny smart objects, the Internet of Things, fostering the idea of PCEs, or pervasive and cognitive environments, where all the data gathered by the things in the Internet of Things can be elaborated by cognitive systems and used to improve livability, safety, security of the environment, and make life easier. To meet the requirements, telecom systems should deliver significantly high data rates, traffic capacity, connection density, energy efficiency, as well as small latency. Matched distributed environment, cognitive objects may generate, collect, and exchange and process big data, provide serves other computation resources, and cooperate to perform some tasks locally, as well as delegate their execution of more powerful nodes and networks. So the cognitive environment track aims to solicit the collection of innovative papers reporting the most recent advances in the field of smart architecture, protocols, and informations enabling IoT for smart environments. So this isn't like cognitive science per se by any means, but interesting the idea of a pervasive and cognitive environments, sort of like the brains of a lot of IoT integration, if you will, which I use that word very loosely, but sort of the mesh point and how they're trying to work that out, how they're doing drones and security, crowdsourcing efforts. And I'm curious about their test beds as well. So that's one thing, but also like I will, for a variety of other interests, I'll be looking at. I am going to be checking out the blockchain stuff because I've been asked for a few different reasons to look into that, and maybe cognitive computing stuff if possible for general AI, things. But if anybody has any particular interest in that, it is free to join, free to register, or if you want me to scout something on your behalf, let me know. I'll be there. I'm going to try to go there as much as I can with a special highlight on. I'll definitely be there for probably the general IoT session, probably eHealth, and definitely the blockchain stuff, and I think Regazzoni, isn't that one of the people here?
It could be.
No, it's not.
Oh, okay.
I'm being a little too simple in my name. At any rate, that's the conference, and we can move on to other things. The only other stuff, any particular questions about that? I don't want to linger here too long.
Well, I think that's great. Please give a report on that. It'd be interesting to see what they were thinking about in terms of, we've talked about swarm intelligence and distributed systems before. We haven't talked about that topic in a while, and so it'd be interesting to see what they're doing.
I think this will be and just to kind of reiterate this, it will be probably a little bit more of a hardware conference than what we usually get into.
Right.
But I'm going to try to be scraping the edges of what they're doing. How they're basically, I'm going to go to look, how is the technology going to afford certain things, and a lot of it in cognitive stuff, a lot of it in like Internet of Things in relation to like AR, VR stuff, like I've been mentioning for a while, is going to be a thing, and you know, cognitive related stuff. So I'll be looking at that.
Oh, we lost you. You were muted.
Whoops. I found this through basically my doing some research for my other position, let's call it.
Yeah.
So I'll be there for that. And we only have 20 minutes left. Really quickly, just to put it on here, I'll say more of this next week. But I don't know how to even say it. Like, I have received a fellowship,
Okay. Yeah.
and I've talked to Bradley about it, and Bradley knows about it. But just as a teaser for next week, there's a really nice fellowship that's involved with helping me get into grad school, and it's I really like it because it puts an emphasis on people who want to go into research and get a PhD in computing or information science related stuff. And it's very much, one of the exciting things about it is that I think it will really help. It's really nice in terms of its focus on diversity and and education as components for the selection process. They want to hire people who are promoting accessibility for others, and I think it ties really nicely with number one. I'm very happy and thankful to be able to do what I've done in the lab here, and I'll say a lot more about this next week. Because without the lab, I wouldn't be able to do much of what helped me get through fellowship and stuff like that. But also, I think it's kind of I think being a part of the cohort, which is the initial cohort for this fellowship, will open some opportunities to further bring people aboard and be. I don't think this is explicitly stated in the fellowship, but maybe they will say more about this when the program starts. But like, I'm going to use the fellowship as kind of basically a platform within which to further enhance accessibility, outreach, and involvement for people who do want, especially in general, to science and to research and all that stuff. Yes, but also specifically for people who want to do research. And I feel like I really appreciate the fellowship because the fellowship is particularly aware of. It's honestly, I forget how I think I found out about it from reading on Twitter, of course, somewhere, and it's the inaugural version of it, but it's very it's really designed at people who are kind of on the cusp of doing research seriously, or like want to do it in a graduate sense, and I find it to be. I really like seeing those things like that, and I'm happy to find out more of them, and happy that this is the first time this fellowship has been offered, and. So like it really seems to be helping people who are like, right on the cusp of like really seriously doing research long term, because it's geared at people who are like early career, people who have some experience that haven't gotten to grad school yet, geared at people who are like, it opens a lot of doors for people who maybe are just almost there, and then this opportunity and this funding involved and mentoring involved in the fellowship. I think it's a really, it's something. If you could say, hey Jesse, here's a bunch of money and you have free reign to make a fellowship, it would be very similar to this.
Okay.
What they're doing is that they're providing mentorship directly and tagging a lot of like important criteria and selection and importance to really important outreach and accessibility and involvement. And so I'll say more about this next time. I haven't mentioned any names or things right now, but I'm kind of waiting for another week or so. But just like I wanted to express my excitement about it and the fact that um, there are a lot of people, and I haven't mentioned it explicitly to many of my friends, but a lot of my friends, and some of them who are in the lab here, are like, oh wow, I could apply this too, because they're fitting the exact same role as me. People who are
Right.
maybe not students, people who have had kind of weren't slated into 100% research career paths from the start, and they're like, oh, maybe I can, or like I have a natural talent, but I had some roadblocks, I had health issues, that I had, a atypical life path. I had, I'm from a disadvantaged community. Like there's a lot of people who fit into this, and it's an exciting thing to be a part of, and I want to make the most of that. And I really like how the lab has both facilitated that, and the lab can be a arena within which a lot of the values that the fellowship is trying to extol and promote can be realized in. So, I mean, that's a credit to what Bradley's done with the lab. But I'm looking forward to it and more about that next week. So.
Yeah, I look forward to it. Congratulations. I didn't know if you wanted to mention it this week or not, but
that's my teaser preview, and I sort of like impromptu rehearsed what I'm going to say next week, and I'll like show all the information and stuff next week because it's cool, and even also like I said, and we'll talk about this offline, but it's really cool. It's really cool to see because I saw I was graded out, and then you see what it's like a review paper. And I think it's really interesting to see what that is for the fellowship and how people are looking at it in general, and that it offers some insight into some admissions criteria in general, but also like just not for the fellowship itself, but also like for people who are applying to different positions, what things stood out to them. I think that's really important information and would help like in a professional development sense in the lab for others who are concerned about these things. And everybody here is.
yeah.
But this like a lot of cool stuff ahead for that. So I will slip away from the mic and
Okay.
finish our papers and get on with stuff.
Well, yeah. All right. Well, yeah. Congratulations once again. And I look forward. Maybe next week you can present on it a little bit more and give people maybe some information on how to apply if they want to do that for another cycle.
Exactly. This is the first. This is a brand new thing, and I think I understand. Getting all your ducks in a row and doing a new fellowship at a high level. I think I encountered. I had to do some email following up on stuff, but I think it's a great program, and absolutely next time they do it, which I think will just be next year. I think it's going to be yearly and not like. I think most are yearly, but like some aren't. I think it'll be a yearly program, and definitely we can. I think there's a lot of really good candidates already in the lab. I think so. Yeah.
Yeah. Right. So I'm gonna move on to papers. I might go a little bit over on this, but we'll see what we have in here. So I guess a couple things this week. I wanted to talk about this. I found this on. Sort of started as a Twitter conversation. I won't go over the tweet, but I want to talk about some of the papers that I don't know if people are familiar with them. I know that Rob doesn't really attend the meetings, is interested in the history of cybernetics, and Jesse, of course, knows a lot about cybernetics. So I go over this, and this actually goes back to this paper that we've been working on with that Rob and I put out in 2015, and I think Jesse. We talked about doing a new version of this paper, but there's a part in here where we talk about mental models, and we don't really cite these papers that I'm going to go over. So that's why I wanted to go over it. But there's this paper by Arturo Rosenbluth and Norbert Wiener. Norbert Wiener, of course, is very famous in cybernetics, but Arturo Rosenbluth is actually from Mexico. He was a physiologist who was interested in cybernetics. And so, like a lot of people in this community, it's very interdisciplinary. So, this is the role of models in science. So this kind of goes into like building a model in your head, but using this for scientific inquiry. So the intention and result of a scientific inquiry is to obtain an understanding and a control of some part of the universe. So this is an idea of control, but it's sort of applied to something that you want to know. So we talked about, I think Jesse did a YouTube talk on mastery and some of the stuff that the cyberneticists talked about with respect to skill mastery. So this, I think, actually fits into that. This statement implies a dualistic attitude on the part of scientists. Indeed, science does and should proceed from this dualistic basis. But even though the scientist behaves dualistically, his dualism is operational, his being like a 1950s way of referring to people, and does not necessarily imply strict dualistic metaphysics. So this kind of goes, this is like a philosophy of science paper, and this goes on about, talking about the investigator, experiment. Experiment is a question. Precise answer is seldom obtained if the question is not precise, so they go on about that. As you can see, like the parts being put together here for sort of a cybernetic understanding of the scientific process. They talk here about abstraction, so no substantial part of the universe is so simple that it can be grasped and controlled without abstraction. So abstraction consists in replacing the part of the universe under consideration by a model of similar but simpler structure. So it's taking a problem and boiling it down. We were talking about that with respect to our equations that we have for things, or algorithms. If you want to take an algorithm line by line and just say this part of this algorithm or this part of this equation means something. It's abstracted from the real world. It's a description. It's written in a symbolic language or a functional language, but it's just taking some part of the world we can model. And so, that can change from wherever you're applying it, but that's what we're doing. So there's a lot of good stuff in here. I think maybe this should be cited in the Metabrains paper, because they did talk about abstraction, something we don't when we talk about representation, and there's a lot there that could be cited. Abstraction, I think, should also be part of that in terms of like, how do you take something and boil it down to its component parts? Material models are useful in the following cases. So they kind of go through these material models, and then into mental models, I believe, where they talk about like a model inside the head, and this dictum that something that's well regulated is a model of that thing. So you're modeling something to basically regulate it or control it. And so I think this fits also though into that paper, the 2015 paper that we did on the ever good regulator theorem. So there's some really interesting connections there. Then there's this book that I don't have a copy of, but I found a couple of reviews of this book. And so this book is The Nature of Explanation. This is by Craik. There's another person in cybernetics, Kenneth Craik, who is maybe more obscure. This was written in 1943, so this was about the time where they were talking, this is early on in the history of cybernetics. And so this kind of reviews the book. And so the book kind of gets into this question, what is explanation? So, it's like the nature of explanation. What is explanation? And they kind of go through here. Methods of testing a hypothesis is another chapter. So they kind of talk about hypotheses and models of knowledge and models of science. And so they kind of walk through explanation as this set of models. And, this is another component of cybernetics, is this philosophy of science component. I talk about a priorism, which is, of course, a priori meaning the prior, right? So we talk about priors a lot. This has roots in cybernetics. But this is it's very vague in terms of our modern technical explanation, I think. But nevertheless, it's in here. And then they also bring up C.S. Peirce, who was a philosopher who was really interested in symbolic models. So they're bringing into the mixed symbolic models and using symbolic methods to look at these problems as well. So then there's actually another editorial from 1983. So this book review was from 1944. This is 1983. And this is 40 years on. So this is 40 years from the publication of this book. This is where they talk about this. Kenneth Craik was a visual physiologist interested in dark adaptation. So this was, kind of before people really started doing stuff with computers. A lot of the cognitive science, for example, and computer models that kind of grew out of that approach. But he's actually trained in philosophy and did some early stuff with cybernetics. In this book, The Nature of Explanation, it shows the power of explicit analogies from technological principles as its central concepts are drawn with brilliant imagination and cogent arguments. And then from the newly invented analog predictor mechanisms of the Second World War. So this is really early on in cybernetics. And he actually got knocked off his bicycle and died at age 31. So he didn't live very long to really kind of write a lot of this out and work a lot of it out. But nevertheless, he did some really good work. They weren't directly influential in the American development of cybernetics. Warren McCullough, who is, of course, the person who did a lot of stuff with early neural networks, or what would become neural networks, the perceptron and that sort of thing, learned of Craik's work and arranged for his papers to be collected by Stephen Sherwood and published under the title The Nature of Psychology. So this is interesting that this got republished. Here I'll only be concerned with the Nature of Explanation book, which introduces his notion of cognitive brain functions in terms of physical internal models. So this is where, we've talked about internal models before, but at a very modern version of them. So there's the version where they talk about the cerebellum being an internal model, or we talk about mental models, which are in cognitive psychology very robust models of the internal state. But, they have their origins in this sort of stuff. And so it's interesting that we're kind of looking at the roots of this, and the roots of this are actually in cybernetics. So that might be an interesting thing to draw out in the future, is to know kind of how these, how the connection between cybernetics and the work on mental models and all that come together. So this kind of goes over this. This is a sort of a 40-year revisitation of this. And then this is an example from chapter 5, which is hypothesis on the nature of thought. So this is, kind of gets into some of this.
Put that in the channel or the Slack, the folder for the...
Yeah, I'll share it. I can put it in the chat here, and then I'll put it in the Slack later.
Yeah, that's
yeah. And so, I just... Quickly, I'll go over look at chapter 5 here. This is the hypothesis on the nature of thought, and then this is from this point onward we are advancing a hypothesis and shall take the existence of the external world and of causation for granted. I think these are notes from this chapter excerpts. So you have this translation of external processes into words, numbers, or other symbols. You have the arrival at other symbols by a process of reasoning, deduction, inference, and then a retranslation of these symbols into external processes as a building a bridge to design, or at least a recognition of that correspondence. So, I was talking before earlier in the meeting about this this category theory model. So in category theory, of course, you have categories, but you also have this transformation or this morphism. And so here we're talking about a similar thing between the internal model and the external world, where you have actually a dual process. You have a category in the external world of all things, and you have this morphism which transforms that into an internal model. Actually, there's also this process of abstraction, of abstracting things from the world and putting a subset of those in the internal model. Then you have to do another translation or a morphism to the external world again, to sort of map things from that internal model outward. So it's kind of an interesting sort of setup. And then, of course, there's this, you can build a cybernetic model of that as well that describes it in terms of regulation, or, however you want to do that. So that's something that maybe is, something that I don't think people have thought about that way, but it's definitely not the way people think. Well, people don't really think about internal models that way nowadays. Nowadays, people are looking for, sort of like things that, in the cerebellum, for example, they look at motor control. They look at the speed of an effector or the alignment of an effector. And so those things are sort of, we're a mental model where you're mapping things to maybe the external world or what you're remembering. There's a lot there, I think, that could be developed. So I don't know what the answer is here. It's something for future exploration. There's a lot of good stuff in here, though, and it really does. Again, you can explore more about it. I didn't want to get too deeply, but I think the take-home of this is that there's a connection between these internal models, these sort of models of a system, the EGRT, which is the Evergreen Regulator Theorem, and maybe some things with the brain and with AI models like the Metabrain models. So let's see. I go on to another topic here. This is the one I wanted to talk about, actually, the category theory of games. So Jules Hedges is actually the person I saw give a talk on this in that category theory seminar I told you about. And so he's been working on this idea of open games. And so describes what open games are in this paper, and they're very closely tied to category theory. So the abstract reads, game theory is used by all behavioral sciences, but its development is long centered around tools for relatively simple games and toy systems, such as the economic interpretation of equilibrium outcomes. Meaning, it's something that, you can model a theoretical system, and you can do that really well, but if you want to deal with, maybe real-world settings that aren't particularly well understood out of equilibrium systems, then, it's maybe not as powerful. Our contribution, which they call compositional game theory, permits another approach of equally general appeal, and that is the high-level design of large games for expressing complex architectures and representing real-world institutions faithfully. Compositional game theory, grounded in the mathematics underlying programming languages. So, this is if you know anything about object-oriented languages, you know that there's this modeling of objects and modeling of states and modeling of instances and all this. And, it's a way to kind of it's a sort of a supervised version of, we don't really, I don't know. I mean, I guess you could use object-oriented programming to model data, big data and things like that. But people generally don't. They just use it to describe a world in which they want to do something, like build a video game or build some other program. And so in this case, they're using something kind of similar to this, but they're using it as a way to interpret the world and to model it as a game. And then this model isn't really object-oriented programming, which is more like traditional set theory, but it's more like a category theory approach, where you have categories and these transformations, these morphisms, and then other things that are going on that enrich the model. And so they use this general computational framework. They have representations that have abstraction and modularity. It accelerates search and design and helps theorists across disciplines express real-world institutional complexity in well-defined ways. So they go into the introduction. This is where it gets a little tricky, because you have to kind of get around some of these terms. Some of them, like monoidal, is a mathematical term, and so this is a morphism where the objects x and y describe the boundaries of an open system. This is notable because of the connection it reveals between the structures of game theory and software architecture. Classic models of computation, such as lambda calculus, have been productively modeled using category theory. So you can use category theory to model models of computation. That's been demonstrated. As well as abstraction and modularity, open games admit a formal graphical representation that is closely related to other formal diagrams, such as Feynman diagrams. So we haven't talked too much about systems diagrams, but you could, this is something we do in cybernetics, I guess. The visual or the graphical representation is often very important for understanding a lot of these processes. It makes it a lot easier to get a handle on. Framed within category theory, a game is a kind of process following the arrow of time, which is, basically following the flow of time, and of course there's also, you're dealing with conservation of energy and entropy and all these things from past to future. So, you can't be retrocausal, you have to be forward causal in your game. And the basic unit of categorical game theory, the open game, generalizes a game so that it can communicate with an external environment through its inputs and outputs, which define its type. So this is where you have, it's almost like a cybernetic type model where you have this communication with it's an open system, you're communicating with the environment, you're producing something at the end, and there are a bunch of transformations and feedbacks and things like that. Open games connect along their type boundaries to compose into larger open games in such a way that each component becomes a part of the environment of the others. So in this case, when they talk about compositionality, they mean that you can take a small game, you represent a system. Sometimes finding a boundary is hard. So what you can do is you can take reality and break it down into a series of modules, each having their own game. And then those games are combined as you observe the environment. So if you observe some part of the environment, like some process, like a plant undergoing some growth process, you can model that growth process as a game. But then there are other things in the environment, like the soil or other types of the weather. Those things can be modeled as a game, and they fit together because they all affect each other. And so then that's all open to the world. And that way you can connect these things. Now I'm using an ecological example rather than a social example, but I think it works in a similar way. This is directly analogous to how modern software is built by connecting standard components, such as functions, classes, and modules, to well-defined interfaces. In fact, the analogy is direct enough that string diagrams out of open games can be directly compiled to software, and are subject to formal guarantees, such as the guarantee that any composition of open games will be another well-typed open game. So this is kind of an example of the operations that you can conduct here. This is the standard representation in a tree. This is the computational representation in a sort of a block and arrow diagram. These are transformations that show how this can be applied. And then this is the string diagram of an n-choice two-player game, where you have player 1 and player 2, and you have payoffs for each player. And then you have these, players can take, one of two payoffs, and then there's a feedback to their next decision, which then continues on. And so this is all oriented in time, right? This payoff structure, it goes in one direction, despite the feedback to the player. This all plays out, so you get a string of payoffs, and then this is your motivation. It's kind of very much, you can connect this to reinforcement learning. And then this is a 4-stage CO2 market game. So this is for looking at, I think, carbon credits or something, where you have this behavior where you want firms to do something. You're allocating carbon credits to the firms, and there's this allocation, production, and resale functions that are kind of modular, and then their interactions are captured in games, and then these games are composed across this decision stream where they're actually producing something and they're valuing their permits, and there's a feedback there. So they're able to get this complex system modeled in this sort of method where you're modularizing the problem, you're building a game around each of these modules, and then you're connecting them together. So that's all I'm going to say about that paper. I think it's a good paper. I'll put that in the main folder, and I'll put that in the chat, and then we can I'll put it in the Slack as well. So, all right, so that's all I'm going to talk about for today's papers. Jesse, did you have any comments on that? Any of that?
No. Oh, sorry. That sounded really weird. No. What is that like? No, but I'm going to reach them, and they're good papers. I'm going to reach them, and I think I'm realizing how rusty I feel about lab stuff and paper stuff, and I think I'm going to start presenting some papers myself soon again. I haven't done it in a while. Just sort of getting back into like actual researcher mode, because I haven't. Oh, it's just weird. It's like I'm having memories of like this time last year or even before the summer. It's like, oh yeah, like I would or like going through our the GitHub project board with the tasks and everything. We did an actual like task orientation. That's a little bit. I wouldn't have to see it all again, but papers are good. I'll have to start doing that myself again. And a lot of work on prepping stuff to advertise and hopefully some other people for fall. This is on my mind right now, but it was a good meeting otherwise, and thank you for everything.
Yeah, no problem. And thank you for all your work on the administrative side. And looking forward to hearing more next week. Next week, we'll have different topics. We'll follow up on some things, and if people want to present something, you're welcome to do it. And hopefully Jesse can tell us a little bit more about this fellowship. It sounds exciting.
Yeah, that'll be cool. I don't know if that actually starts next week or in September, but I'm hearing more back from it this weekend, so it'll be good. Yeah, it was good to talk, and hope everybody's doing well, and take care.
Yeah, take care. Have a good week.